Okay, we're just about done with chapter 1. We've got a couple sections left dealing with functions. This is chapter 1, section 6. And we're going to be talking about functions today, functions as rules and tables. You have two objectives for the most part. First, can you take a function and write it as a rule and then create a table from that? And second, when you read a problem, can you identify what's the dependent variable and what's the independent variable? So there's a lot of vocabulary in this part of the section, or part of the chapter, I should say. I don't think you're going to find this too difficult, but pay attention, and especially to the vocabulary and the words that we're going to be using. Now, we're talking about functions. Let's pretend you're pumping gas in a car. The cost of the gas depends upon the number of gallons that are pumped, obviously. So the more I pump, the more you pay. That makes the cost a function of how many gallons are pumped. And you've probably seen this graphic before when you were younger of something like a function machine. Function machine is kind of like an input-output kind of a thing where you put something in, you apply a rule, and you get something out. So an example would be if the rule was times 2, if you put in 2, apply the rule, times 2, that would give you 4. And if you put in 10 and applied the rule, 10 times 2 would give you 20. So you put something in, you get something out. And the output depends upon the input. And that's kind of what we're talking about when we have the independent and the dependent variables. So let's talk more about the things that a function has. And these are important because you're going to follow these things, these will follow us all the way through the text throughout the entire course. So the first new word is domain. Okay? The domain of a function are all the numbers that can be considered the inputs. It's kind of a set of numbers. The range is the set that contains all the outputs. And you're going to get this later, but just so you know, the domain values are the x values, or the inputs, and the range values are the outputs, they're the y values. And one thing that's important to know about a function is this. Function has pairings. That means we pair the input with the output. But it's important that for a function to be a function, each input has exactly and only one output. Because we're applying the rule, every input has to follow that rule. So if it follows the rule, there can only be one output for every input. And again, you'll see examples of this as we go along to make it hopefully a little bit more clear. Okay, so now we go back to the gas example. We know that the input values are the number of gallons that we use. So if I put in, here's just 4 examples, 10 gallons of gas, 12 gallons of gas, 13 or 17. Those are the domain. Those numbers make up the domain. Now, I'm not sure when this book was written, but at the time it looked like gas was about $1.99 a gallon, or about $2 a gallon. So you can see that if I put in 10 gallons of gas, it's going to cost me $19.99. If I put in 12 gallons, it's $23.99. 13 gallons are just about $26, and 17 gallons comes out to about $34. So it's about $2 per gallon. So if you're asked what's the range would be, the domain. The domain would be 10, 12, 13, and 17. That's the numbers that make up the input. And the range are the numbers that make up the output. And those are the 4 prices. So it's pretty simple to this point. So remember, input, output, domain, and range. So take a look at the table that's in front of you now. The input values are 0, 1, 2, and 4. The output values are 5, 2, 2, and 1. That means the domain, sorry about that. Let's go back one. Sorry about this. That means the domain for this is going to be 0, 1, 2, and 4. And the range would be 5, 2, and 1. Since we have 5, you don't have to list 2 twice. The domain would be, the range would be 5, 2, and 1. Sorry about that. Now, this is important. It's what we discussed just a few seconds ago. For a function to be a function, each input can only have one output. And I'm going to show you like a picture of this so you understand kind of how it works. And again, that's because if it's following a rule, the number always has to come out the same. Meaning if the rule is times 2, we put in 1. 1 times 2 is 2. Well, if we put in 1 a second time, it can't come out as something other than 2, other than it broke that rule. So let's take a look. Here's our domain on the left. Here's our range on the right. So 1 is the input and outcome 0. 3 is the input, outcomes 2. 4 is the input, outcomes 2. And 2 is the input, outcomes 1. This is a function because each one of the inputs has exactly and only one output. But now if we look at the second example over here, the input values, or the domain, are 0, 5, and 10. But if you look, 0 has two different outputs that it's connected to. That means this isn't a function. It's okay if the range has the same number being used more than once. But here we can't go from 0 to two different output values and have this still be a function. For the second example, so that's no, each of the input values, each of the domain values, has exactly and only one output values, which means that yes, this is a function. Okay, so here's the guided practice questions from your book. We have an input of 3, output of 1, input of 6, output of 2, input 9, output 2, input of 12, output of 1. What do you think? This is, yes, a function. Okay. Down on the bottom, though, we have input of 2, and we get an output of 0. Put in 2, out comes 1. Already the red flag should be going off in your brain saying that this can't be a function because the input value cannot have two different output values. So the first one, function, the second one, obviously not a function. Okay, now we're going to talk about rules. And a function can be, well, there's 4 representations of functions. That's the verbal, or the words that make up the function. The rule, or the equation, we can put it in a table and we can put it in a graph. So we can represent a function 4 different ways. Now we're going to be representing the function as a rule. We said this before. The independent variable is the input, and the dependent variable is the output, meaning the output depends on the input. The number of gallons of gas, the independent variable. The cost of the gas is the dependent variable because it depends upon how many gallons are put in. Okay, so again, just a few more words for you to remember. So here's what we're looking at. The verbal rule, say for this example, would be the output is 3 more than the input. That's the verbal rule. The equation would be y equals, so output is y equals 3 more than the input. That means y equals x plus 3. Now the table, this is new and this is what you're going to be doing right now. The table would be to put in some values, put in some numbers in the domain, and figure out what the range values would be. So in this case, I put in the numbers 0 through 4. So if I put in 0 and add 3, I get 3. If I put in 1 and add 3, I get 4. 2 plus 3 makes 5, and so on. You can see that here's a word representation. Here's the function written as an equation. And then finally we have some values put into a table as ordered pairs. That's our table. Okay. Now you can be asked to do this for your homework and for just classwork. So read through it. It's pretty simple. Okay. They're telling us that the function is y equals 2 times x. And they're also telling us that the domain is 0, 2, 5, 7, and 8. So we have to make a table and then find the range. This is actually pretty simple. So we make our table, and we know the x values are going to be the domain values 0, 2, 5, 7, and 8. We know the rule is to multiply by 2. So we're going to multiply each of these values by 2, put them in the second row. So when I multiply by 0 by 2, I get 0. Multiply 2 by 2, I get 4. 2 times 5 is 10. 7 times 2 and 8 times 2. You can see the numbers. I also just found the range because the range are going to be the numbers that make up the y values. So I can say the range is 0, 4, 10, 14, and 16. I hope I'm not going too fast for you. And if I am, remember, you can always rewind this and go back. But if you think about it, it's really not that difficult what we're doing right now. They're telling us, here's the input x, here's the output y. If I put in 0, I'm going to get something out. If I put in 2, I'm going to get something out, and so on. Okay, so now this time, they're asking us to write the rule and find the range. Well, first, finding the range is pretty simple. It's just 0, 4, 10, 14, and 16. And if you look at the relationship between the input and the output, for every input, the output number is exactly twice what the input is. So the rule would be y is equal to 2x. We just saw that one. And we know that the range is 0, 4, 10, 14, and 16. Okay? This is basically the same example we just did. Here's a few more. So what do we have to do to x to get y? In this case, for each of these values, if we multiply by 3 and then add 1, we get the output value. So if I do 3 times 2, 6 plus 1, I get 7. 3 times 4 plus 1, I get 13. 3 times 6 is 18, plus 1 is 19, and so on. So the rule for this one is 3x plus 1, or multiply by 3 and add 1. How about this one? This one's a little more complicated. But if you're in my math class last year, Math 7-8, we did similar stuff like this. If you remember slope and intercept, we're basically kind of in the beginnings of learning about slope and intercept. We know there's got to be some subtraction in this one because we got a -3 over here. Pause it if you have to. See if you can find the rule. If not, I'll tell you what it is when you press play. All right, in this case, it'd be kind of easy to say multiply by 3, but that wouldn't work because 4 times 3 is not 12, 2 times 3 is not 5. Okay? So we're going to have to find a different rule. This one has 2 steps. The first step is to multiply the number by 4. So if I multiply the number by 4, the input value, and then take away 3, everything works. So 4 times 1 is 4, minus 3 is 1. 4 times 2 is 8, minus 3 is 5. 4 times 3 is 12, minus 3 is 9, and so on. The rule here is y is equal, or the rule is multiply by 4, subtract 3. All right, we're just about done. We have one last question. That's this word problem. Take a second and read it, and we'll solve it on the next page. All right, so they're telling us that we have the opportunity to buy some tickets for a concert, and the tickets are $15 each. You can only buy up to 6 tickets, though. So we have to write a function that compares the number of tickets with the cost, identify the range, and we're going to find the independent and the dependent variables as well. So here's the problem again. Now, first off, think input, output. In this case, the input would be the number of tickets, and the output would be the cost of that many tickets. And since each ticket costs $15, sorry about that, we're going to say that the function is a equals 15 times t. That's the total amount is equal to $15 times each ticket. And we've been using y's and x's quite a bit. So if you put y equals 15 times x, that would be okay too. Now, the independent variable is going to be the number of tickets, because you have control over that, right? The number of tickets you buy kind of determines how much money it is that you're going to be spending on those tickets. So that means the dependent variable is going to be a, and it's the cost of the total cost of all the tickets that are bought. And again, we've been using y's and x's, so if you put y equals 15 times x, I suppose that's okay, but in this case, I think they want you using the letters that make more sense to this particular problem. Okay, so we know the independent variable, we know the dependent variable. Now we're going to find the range, and we're going to make a table. So do this with me. First, we know that our equation is total amount is equal to 15 times t. And they kind of, in a way, they didn't really directly tell us, but they told us what the domain is. The domain says we can only buy up to 6 tickets. That means we can buy 0 tickets, 6 tickets, 3 tickets, anything in between. So the domain is going to be the numbers, the whole numbers, 0 through 6. Now, finding the range is pretty simple. We just multiply each of those by 15, and these are the numbers that we get. So 1 ticket's $15, 2 tickets are 30, 3 are 45, and so on. So when it says to identify the range, we just did that. The range is going to be, oh, there's a domain first, I'm sorry. The range is going to be 15, 30, 45, 60, 75, and 90. And actually 0, too. Should be there. I mean, but I don't know why we'd have 0, because if we're going to buy tickets, we're going to buy at least 1, right? So the big ideas so far are these. We have things called the domain and the range. The domain are the numbers that make up, the set of numbers that make up the input numbers. We have the range, which are the numbers that make up the output numbers. In a word problem like the one we have here, we know that the independent variable causes the dependent variable, meaning the total number of tickets is dependent upon how many tickets are sold. So we have the independent variable and the dependent variable. There's a lot here. It's not really the hardest stuff in the world, but it's something that's probably new to you and something that's got to kind of like sink into your brains because we are going to be doing this quite a bit. That ends the lesson, which is kind of nice. The homework isn't all that difficult or all that long either. Look at page 38 in your textbook. Check your map. I don't have the numbers available with me right now. I think this homework is due in a couple of days, along with the 1.7 homework. You will be having a test later this week too. All right? So if you have any questions, look over in your book. Ask me if you need some help. Thanks for watching, and again, for your participation in this class.